Hello, Mario! In this video I'm going to take a look at working out the area of some other regular shapes that are not triangles or rectangles. In particular, we're going to possibly be looking at the trapezium and the parallelogram and some of the regular polygons. Right, first up we're going to be looking at the parallelogram. So we perhaps need to get a bit of a heads up on what a parallelogram is. A parallelogram is essentially a four-sided polygon which has two sets of parallel sides, not necessarily the same length. So here we have this longer side here, parallel here, and these are two sides ones here, parallel. So these two are parallel, these two pairs of parallel sides. They're 8 meters apart. Effectively, we can refer to that as the height of the parallelogram is the distance between the parallel sides, and that's the parallelogram. It has a number of other properties, and it sort of comes up from time to time, particularly where we have a four-sided polygon where the angles are not necessarily at right angles, and therefore they're not rectangles. So the area of a parallelogram is equal to the base times height, and or BH. You'll notice that when we looked at the triangle, the area of that is half base times height, and you can see if you were to draw a little line across the parallelogram, you could see how that half the area of the parallelogram is in fact the area of a triangle with the same base and height. So the area of a parallelogram is base times height, BH. Let's fill in what we know, 12 meters times 8 meters. 12 eighths are 96, and 96 meters squared. Fairly simple. Area of a parallelogram. Okay. Now, let's moving on. Find the area of the trapezium below. Now, a trapezium is described as a four-sided polygon which has one set of parallel sides. So, although a parallelogram is in fact a trapezium, not all trapeziums are parallelograms. So here we have, in this example here, we have a trapezium ABCD, and I've given this side here the letter A and this one here B. There's no particular thing, it's just that the lowercase letters stand for the length of a side. And again we have our parallel lines with the distance between them, which is in fact becomes the height of the trapezium. So the area of a trapezium, and I've written it out here in full words here, area of a trapezium is equal to half the sum of the parallel sides times the distance between them, which is in fact the height of the trapezium, the distance between parallel lines being the height. So, if we want to write that in sort of using letters and algebraic terms, that's A plus B over 2, which A and B being the sides, the parallel sides of the parallelogram, and there we've got half of them. And then that's multiplied by the height, or the distance between them. So, filling in what we know from the formula, it's 14 meters. Is the length of side A plus 18 meters the length of side B, and that's divided by 2, and that's multiplied by 8 meters, the distance between the parallel sides. So 14 plus 18 is 32. Divide that by 2, 16 meters. Remember, if adding meters, so it's meters times 8 meters, and when we multiply that out, 16 by 8 is 128 meters squared. So that would be the area of that trapezium. And we'll now move on to some more shapes. Right, So now let's look at what we call some of the regular shapes, and these are shapes where all of the sides are the same length and they all have similar angles as a result. So we have our regular hexagon, pentagon, depending on the number of sides. A square, of course, is a regular four-sided polygon, and the triangle, the equilateral triangle, would fit into this with regular, where all of the sides are the same length and the angles at each of the corners of the polygon are equal as well. So in this case here, we've got find the area of a regular hexagon inscribed in a circle radius 6 meters. So we can see there that that would be how that fits there. It's inscribed in the circle. So each of the corners of the hexagon sit on the circle, which means that the green lines that I've shown in there are all radii of the circle. They're all 6 meters long. And if we look at the angles, they will all be equal, especially the angles at the center of the circle. And as there's 360 degrees in the circle and there's 6 angles at the center, they will be 60 degrees. Now, it also follows on from this that the 6 triangles that we've divided this shape up to will also have an equal area. So if we can find out the area of one of the triangles and multiply that by 6, that will give us the area of the whole hexagon. Now, in this particular instance here, we have not got the height of the triangle, although we could work it out using Pythagoras, but we're going to move on to that a little bit later on in this series of videos. But we do have the formula for the area of a triangle, the second one, which is the area of a triangle equals a half BC sine A. So what I've done here is drawn out a sort of triangle in that vein here in the magenta. So we've got a triangle with 2 sides 6 meters as shown, and the angle at the center is 60. So I'm going to work with that triangle. So filling in the information we know, it's half times 6 meters times 6 meters, being B and C, times sine 60. And we do that on our calculator, and we should get something like 15.588 At this point here, I've taken broken with my previous things that I've done, and I have actually what I've done here is I've written down the number that comes out there, but I've still retained that in my calculator and then carried it forward. I've multiplied that by 6, and that would give us 93.530,743,60872, and so on and so on. And so I've chosen to round that up to 93.53 meters squared and to 2 decimal places. So there we are, finding the area of a regular hexagon, and this would work for any regular feature or regular sort of shape or polygon, depending, whether it's 5 sides, 6 sides, 7 or 8 sides. Obviously, there'd be different numbers of triangles. So what we can see from all of this is that most regular shapes have a formula for the area and perimeter. So if you're using or continually finding the area of a different sort of regular shape quite regularly or often, then it would probably be worth your while to seek out what the formula is. Possibly use the formula, put the formula into some sort of spreadsheet so that you could very quickly work out the area of that shape if you're doing it. But if you're just doing it on a not very often, one-off sort of basis, well, that's probably a bit of a not the best use of your time. Now, the formula for these shapes are available on the web, World Wide Web, and all you need to do is find the correct formula and then fill in the values. And so if you want to find out the area of 86-sided figure. I'm sure you could find out what there would be a formula for that. However, and this is what I've sort of demonstrated here, most shapes can be broken up into triangles. Well, all shapes can be broken up into triangles. And other shapes, you might want to use rectangles, parallelograms, trapeziums. These are the common ones that you should or be certainly familiar with the formulas for. And so the area can be determined as the sum of the area of each of the shapes that you've broken it up into. And we will be looking at this a bit further down the track when we look at working out the area of compound shapes. So there you have it, a little bit about finding the area of regular shapes and polygons and things.